Now, at this point, we can perform the calculations for the magnitude of the cross product and also calculations of the cross product of standard unit vectors. However, we haven't learned anything about how to obtain the value of the vector or the components of the vector after performing the cross product. So here in this particular topic, we're going to learn how to evaluate the cross product given two three-dimensional vectors. So when you let u equal to u1 times I plus u2 times j plus u3 times k, and v is equal to v1i plus v2j plus v3k, we're going to do a kind of the derivations for the formula. That is, when you do u crosses with v, you get u1i hat plus u2j hat plus u3k hat crosses with v1i plus v2j plus v3k. And we're going to do distributions. And again, when you do distributions, you have to be careful with the order of the calculations. If a vector is on the left of the cross product, keep it on the left of the cross product. If a vector is on the right of the cross product, then keep it on the right of the cross product. So now you distribute u1i into v1i. You get u1i hat crosses with v1i, and so on and so forth. So u1i crosses with v2j plus u1i crosses with v3k, then u2j crosses with v1i plus u2j crosses with v2j plus u2j crosses with v3k, added with u3k crosses with v1i plus u3k crosses with v2j plus u3k crosses with v3k. And remember u1, u2, remember u1, u2, u3, and v1, v2, v3 are just constant. So therefore, you can take the constant out of the cross product operations. So you get u1 v1 times I crosses with itself plus u1 v2 times I crosses with j plus u1 v3 times I crosses with k plus u2 v1 times j hat crosses with I plus u2 v2 times j hat with itself crosses with itself plus u2 v3 times j crosses with k plus u3 v1 times k crosses with I plus u3 v2 times k crosses with j plus u3 v3 times k hat crosses with itself. So from the results that we get earlier on the cross product of the standard unit vectors, you can see that I crosses with itself will give you a 0 vector, so this becomes 0 vector. J crosses with itself also give you a 0 vector, and K crosses with itself will give you a 0 vector. And also we're going to follow the calculation of the cross product between the standard unit vectors. We have I crosses with j will give you k, I crosses with k will give you negative j, j crosses with I will give you negative k, j crosses with k will give you positive I, k crosses with I will give you positive j, and k crosses with j will give you negative I. So therefore the cross product becomes u1 v2 times k hat plus minus u1 v3 times j hat. So y is negative here because you have negative j. Next, you have negative u2 v1 k hat plus u2 v3 I plus u3 v1 j hat minus u3 v2 I. Next, you're going to combine like terms. So anything related to I, you put them together. Anything related to j, you put them together. And anything related to k, you put them together. So now you have u2 v3 minus u3 v2I plus u3 v1 minus u1 v3 j hat plus u1 v2 minus u2 v1 k hat. So by conventions, what I'm going to do is I'm going to take negative sign here between these two terms as a common factor, or you bring the negative sign out, and you get u2 v3 minus u3 v2I minus u1 v3 minus u3 v1 j hat plus u1 v2 minus u2 v1 k hat. By pulling out the negative for the middle term, this allows us to turn this into something called the determinant of a matrix, and which allow us to calculate the cross product between the two vectors a lot easier than just memorizing the formula. So the formula to calculate the cross product between the two vectors is going to be, so you have u crosses with v is equal to the determinant. So you have the two big vertical line like this. You have three different rows and three different columns of this determinant or the matrix. Because we are considering three-dimensional vectors, so the first row consists of the standard unit vector of I, j, and k. In the second row is the entry or the component of the first vector in the cross product, in this case a vector u. So you have u1, u2, u3. And the last row will consist of the component of vector v, which is the second vector in the cross product. You have v1, v2, v3. Now, how could you get back the formula we just obtained here? That is, what you do is you start with this I. When you start with I, you write like this. You're going to delete the corresponding column and the corresponding row, and you left with the entry of u2, u3, v2, and v3, and you form a determinant as well of those values. That is the determinant of u2, u3, v2, v3. So now that's just for the first term of the calculations. For the second term of the calculations, you move on to j hat, and when you do that, when you switch the column or row, you're going to turn to negative j hat. Similar to the last calculations, you're going to delete the corresponding column and the corresponding row, and you left with the entry of u1, u3, v1, v3, and you form a determinant using those entries. So determinant of u1, u3, v1, v3. Next, we're going to move on to k. Again, when you switch the column, you're going to change the sign of the calculation. So you start with positive always, and then when you switch to j, that's going to be negative, and then you switch to k, and you turn to positive again. So you have plus k hat. You choose this value, and then delete the corresponding column and the corresponding row, and you're left with the entry of u1, u2, v1, v2, and you're going to form a 2x2 determinant using those values. So u1, u2, v1, v2. Now, how could you obtain the 2x2 determinants to arrive at the answer that we get up here? What you do is that the formula for the 2x2 determinant is equal to the product of the main diagonal, subtract the product of the off diagonal. So what you have is u2 v3 minus u3 v2. Similarly, for the second term, you have negative j. You're going to do the same. That is, the 2 by 2 determinant is equal to the product of the main diagonal. Subtract the product of the off diagonal. So you have u1 v3 minus u3 v1 plus k hat. Again, for the 2 by 2 determinant, you do the product of the main diagonal, subtract the product of the off diagonal, and you get u1 v2 minus u2 v1. And that is how we use determinant to determine the value or the component of the cross products. We're going to apply this formula or this technique on some example. So let's move on to example 4 here. You are given two vectors u and v, given that u is equal to 0, 2, 1, and v is equal to 3, negative 1, and 0. So I'm going to perform the calculations to obtain the component of the cross product u crosses with v and v crosses with u. So for u crosses with v, we're going to form a determinant like this with two big vertical lines. There consists of 3 entries of 3 rows. The first row consists of I, j, and k. The second row consists of the component of the first vector in the cross product, which is u in this case. So you get 0, 2, 1. And the last row consists of the component of the second vector in the cross product, which is v in this case. So you have 3, negative 1, 0. Now perform the determinant of the 3 by 3 matrix. So you're going to start with the first entry here for I. You're going to delete the corresponding column and the corresponding row, and you arrive at just the following values: 2, 1, negative 1, and 0, and we're going to form a 2 by 2 determinant on that. So 2, 1, negative 1, 0. Then we're going to move on to the second value, which is j. And when you switch to a new row or a new column, you change the sign of that entry, so negative j. Multiply with the 2 by 2 determinant of. So remember, when you choose j, you're going to delete the corresponding column and the corresponding row, and you're left with the entry of 0, 1, 3, 0. And we're going to form a 2 by 2 determinant on those values. So 0, 1, 3, 0. Then you move on to the last entry, which is k in this case. When you choose k, you switch to another column or row. You switch to another column, and therefore you change from negative to positive. So here you have positive k, and you multiply with the 2 by 2 determinant, where's the entries it's going to be. So you delete the corresponding column and the corresponding row, and you left with the entry of 0, 2, 3, negative 1. And you put them in the 2 by 2 determinant here, so 0, 2, 3, negative 1. Now you need to calculate the 2 by 2 determinant to arrive at the answer. So the 2 by 2 determinant is calculated as the product of the main diagonal, so 2 times 0, minus the product of the off diagonal. So that's the first entry. Now for the second entry, again, you do the determinant of the 2 by 2 matrix. That is the product of the main diagonal, subtract the product of the off diagonal, plus k hat times 0 times -1 minus 3 times 2. So we're going to get, so this is 0 minus -1, so it becomes +1, so it's just 1 times I, or just I for that matter. You have -j times -3, so you have +3 or 3j. And for the last term, you have here 0 times -1 is 0 minus 6, so you have minus 6k. So that is the result of the cross product of u and v. You can rewrite this in terms of the component form as follow. So u crosses with v is equal to 1, 3, -6. You can either perform the calculations on v crosses with u, or you can use the property of the anti-commutative, where when you switch the order of the vector in the cross product, you have the opposite value of the original cross product. So that is v crosses with u is equal to negative of u crosses with v, and therefore this is equal to negative of 1, 3, -6, or -1, -3, 6 for the result of v crosses with u. Now similarly, we're going to do the calculations on u crosses with v, given that u is equal to -1, 2, 5, and v is equal to 4, 0, -3. So you set up the calculations as follow. You form a 3 by 3 determinant, given the first row consists of I, j, and k. The second row is the component of the first vector in the cross product, that is u. Therefore, you get -1, 2, 5. And the last row consists of all the components of the second vectors in the cross product, that is 4, 0, -3. So you do I hat multiply with the 2 by 2 determinant. Remember, when you choose I, you delete the corresponding column and the corresponding row, and you get this is 2, 5, 0, -3 minus j hat times the 2 by 2 determinant. Now we move on to j hat. When you switch the column, you change from positive to negative, so negative j hat, and you delete the corresponding column of j and the corresponding row of j, and you left with a 2 by 2 determinant of -1, 5, 4, -3. Then you turn to k. When you switch the column, you change to positive k, delete the corresponding column and delete the corresponding row of k, and you have the 2 by 2 determinant of the form -1, 2, 4, 0. Then you calculate the 2 by 2 determinant. So the first entry, or the first term, give you 2 times -3 minus 0 times 5 minus j times -1 times -3 minus 4 times 5 plus k times -1 times 0 minus 4 times 2. You got 2 times -3 give you -6 minus 0. So you have -6 here minus j hat. Here you have -1 times -3 is +3 minus 20. And you're going to have -17 plus k hat. Here you got -1 times 0 minus 8. When you simplify, you get -6 times I plus 17 times j minus 8k, or you can rewrite this in terms of the component form as -6, 17, -8. And we have one last example here, example 6, when you do a similar calculations on the cross product between the two vectors a and b. So hopefully at this point you feel comfortable with doing this type of calculation, so therefore I'm going to skip the calculations and just give you the answer That is A crosses with B equal to 8I minus 35J plus 2K, or you can write this in the component form as 8 negative 35, 2. And that's it for me for this lecture. Please let me know if you have any questions. Thank you.